Hi everyone, we're going to cover 4 types of charts in this lecture. We'll go over line charts, slope charts, spark lines, and area charts. We are going to study and learn a number of basic and advanced chart types. We will learn how these charts encode data and how they can be used, and we will see examples of them. Examples of line charts, slope charts, spark lines, and different types of area charts. Line charts are the most basic and simple type of chart used in many different fields. We have been drawing this type of chart ever since childhood without realizing it has a wide set of features and many applications. Line charts display data as a series of data points called markers connected by straight line segments. They encode data using position, and they are usually used to show trends. If you are visualizing a time series, which is almost always the case, it is best to keep the time series on the x-axis and having the oldest time period on the left going to the newest time period on the right. Line charts often show trends over time. Here I have an example to show. This is our data set, which contains the speed of an object at different times. So it is like a time series data. And here is the corresponding line chart, which displays the speed of that object at different times. As you can see, for each data point, we put a marker, here a little circle, and we connect them by straight line segments. So the result is a polyline that constructs our line chart. It should be noted that the number of data points of a line chart should be greater than 2 so that we can use it for trend analysis. Here I'm showing the temperature of a city over a month-like period of time. So we have 30 data points and we can clearly see the increasing trend. In general, line charts are great for trend analysis and for comparing quantitative values. In this example, we have 2 polylines showing the monthly temperature in 2 cities in China. So we have 12 data points on each polyline. I want to point out that it's better not to exceed 5 polylines on the same line chart. As you might have figured out, line charts are similar to scatter plots, except that the data points are ordered, typically by their x-axis value, and joined with straight line segments. Okay. Let's now talk about slope charts. A slope chart or a slope graph uses position to perform quantitative comparisons or rank comparisons, typically between 2 time periods. Slope graphs are basically a simplified variation of line charts that just show the start and end point of the data. Here is an example of a slope graph. We had shown this chart in one of the previous lectures when we went over the highlight color scheme. This slope graph shows the change in sales from 2014 to 2015 in different states, and specifically we have highlighted the state of Washington. A slope graph can be a very useful chart to tell before and after stories. As I mentioned, slope graphs can be seen as simplified line charts that just show the start and end point of each line. Slope graphs are praised for their clean design, and they were first officially introduced by Edward Tofte, the father of modern data visualization. Okay. Let's now talk about another chart type, spark lines. A spark line is essentially a small line chart built to be put in line with text or alongside many values in a table. Because of its small size, it will not include any labeling. Sparklines use position to encode data, and they can be useful to show trends in the data in a very small space. Just like slope charts, sparklines were introduced by Edward Tofte. They are basically a line chart that has been stripped down to just a polyline and made into a small word-sized graphic. Sparklines aren't meant to be used as an alternative to a line chart. They were designed to bring additional context to numbers. Here we show that the glucose level is 128. In approximately the same amount of space that it takes to write glucose 128, we can put a sparkline to visualize the trend leading up to the current glucose level, which is 128. So we are adding useful context. The third line is just a style difference, coloring the dot at the end of the line and the glucose number. The last line has additional context added. A performance band has been added that's colored gray so that we can see the expected range. We now can see numbers that were out of range, both below and above the band. We don't know the time frame of this line or its scale, but that's not the purpose. What we can see is where the number came from. We can see that it came up from a number that was below 128 and it was really high prior to that. So the glucose level of this person might be normal today, but it has been erratic over the measured period. In the stock market world, we see these sparklines a lot. For example, 90% of data visualizations on the Robinhood stock trading app are sparklines. Okay, let's now talk about area charts. Area charts are like line charts, but they color below the polylines to help show the magnitude of trends. So the reason for color filling is to better highlight the trend information. In general, area charts are used to communicate an overall trend without being concerned about showing the exact values. We can have just one category of data, or we can have multiple categories and hence multiple colors. Here is a simple example of a standard area chart with two categories to show a company's financial performance over a 3-year period of time. We are showing sales and expenses at the same time using this area chart. When sales are higher, we are making money, and when expenses are higher, we are losing money. We can easily see that sales for the most part are dominant, and that's good news if we want to look at this chart's overall trend. Again, the color fillings between the polyline and the x-axis line facilitate understanding of the magnitude of sales and expenses. As you can see, the standard area chart is formed on the basis of the line chart. The difference is that the area between the axis and polyline are emphasized with colors in area charts. Here is a more interesting example showing sales of various formats of music, such as CDs, cassettes, and digital formats for downloading and streaming. You might have noticed that there is a bit of problem in this chart, which is, for example, we cannot see the trend for CD sales in early 90s and late 80s because it overlaps with cassette sales. In fact, these categories of data that we have here frequently overlap with each other, so part of the overall trends are hard to see. Sometimes even the beginning and end points are hard to see. What we can do to remedy the situation is to make the colors transparent so that we can see some of the overlapping trend, as you can see here. So, two basic rules for designing area charts are we should use transparent colors so that data isn't obscured in the background in case of overlaps. And for obvious reasons, we need to start the y-axis at 0, just like we did in line charts. Area charts attempt to give a sense of quantity by creating irregular polygons of field color that show the overall trend. However, when the data series overlap, it can be challenging for the audience to gain insights from the area chart despite using transparent colors. As you can see here, different data series occupy the same space, making it difficult to see the trends despite using transparent colors. An alternative, which is more frequently used, is the stacked area chart. Polylines are plotted one at a time, with the height of the most recently plotted polyline serving as a moving baseline. So, the height of the topmost polyline is basically the total when summing across all categories. Stacked area charts are best used to visualize part-to-whole relationships, helping to show how each category contributes to the cumulative total. For stacked area charts, it is recommended that we put the category of data that we care about the most at the bottom, because the polyline at the bottom is the only line that's plotted with respect to the baseline of 0. A percentage stacked area chart is similar to a stacked area chart, but the values are normalized so that the sum across all categories is 100 at each position on the x-axis. So percentage area charts are about shares instead of absolute values. Okay, we want to visualize the historic and estimated world population, and our categories are different continents: Asia, Africa, Europe, America, and Oceania. Here is the standard area chart visualization. We can see that Asia's population has always been dominant, and it has grown at a high rate and is expected to rise at a high rate. Oceania, which is here at the bottom, is hard to see because the population is minimal comparing to all other continents. And as you can see, there is some overlap here that makes it a bit challenging to follow the trends for Europe and America. Here we have the stacked version where the data series values are added together to make up a total. As you can see here, the scale is larger, and this top polyline is actually effectively showing the world population. And this is the percentage version of the stacked area chart, where data series is visualized as a running percentage of the total. So the values are normalized in here. Okay, just a quick summary of area charts. Area charts are great for spotting and analyzing trends and making comparisons. They work fine when we have a small number of categories. Area charts are not good when we want to look at exact values. Area charts tend to have overlapping areas, which may become very hard to follow even if we use transparent colors. Lastly, stacked area charts and percentage stacked area charts are great for part-to-whole analysis. I should also say that comparing to standard area charts, stacked area charts are more commonly used, and they tend to be more effective. Okay, we're going to go over more chart types in the next lecture.